Lesson 2.6, Proving Geometric Relationships. What are the different styles of proof? All right, we've done this in a two-column format, and now we're going to look at it in a different kind of format. It's called a flow proof, where we use a flow chart. Each one of these boxes is a statement. Each one of these rectangles is a reason. And here's our bank of reasons that we're going to use. Let's go ahead and start. This is the given, and notice that I see the given statement right here, so I'm going to write given. And I have used one of my bank of reasons. Now let's take a look at this statement. AB plus BC is equal to AC. Little plus little equals big, and that's segment, addition, postulate. So I've used this reason right here. And I notice that both of these statements, I need to change my color, both of these statements have AC in them. So there's this connection, and I can say these are equal to each other. So that I'm using the transitive property of equality. Now I have one more left, and the one left that I have is I'm trying to get rid of adding AB on both sides, and that's going to be subtraction property of equality. Okay, let's look at another one where we have a bank of reasons. This, again, we've done this one before. So here's my given. So I know I've used given. And then E, and I think I left off the letter, EBA is equal to angle 2 plus angle 3. That's little plus little equals big. So that'll be angle, addition, postulate, and there's two of them, so I'll just cross off one of them. And then it looks like we're taking angle 3 out and putting a replacement in. So that's going to be substitution. I've used that one. And then we have EBA is equal to, it looks like the order's changed, and that's commutative. All right, now it says angle 1 plus angle 2 is equal to CBD. Little plus little equals big. So that's our other angle, addition, postulate. So we've used that last one. And the connection here is this one and this one are the connections. So we can say these two are equal to each other by the transitive property of equality. And again, you can use substitution if you wish. Okay, here's our first theorem for this lesson. It's the right angles congruence theorem. And what I'd like you to do is I'd like you to write the theorem statement, and I'd like you to draw the picture. So that's what you would go ahead and do in your notes right here. You're going to supply that there. Let's take a look at the proof. It's in a flow proof format. We start off with a given, and right angles means they equal 90. And since they're both equal to 90, they're equal to each other, transitive property. And we can change equality to congruence by the definition of congruence. Okay, let's practice doing a flow proof. Without a bank, let's see if we can figure out the answers. Now this symbol means perpendicular. So these are perpendicular. And perpendicular means you make a right angle. Now I don't have enough room here, so I'm going to write a little bit at the top too. So angle B is a right angle, and angle C is a right angle. Now over here we just proved that when you have right angles, they are congruent to each other. So we can say angle B is congruent to angle C, and we'll write, we can abbreviate right angles congruence theorem. Okay, here's two more theorems, and again you need to write the theorem statement and you need to draw the picture. Now let me go ahead, and we're going to prove this, but I'm going to use numbers just to help you. It says that angle 1 and angle 2 are supplementary. So let me make up some numbers that make supplementary. And it says angle 3 and angle 2 are also supplementary. Now we've already talked about angle 2. We've got to force these to be supplementary. So that means that has to be 30. So what the theorem is saying is if these two add up to 180, these two add up to 180, and they are supplementary to the same angle, this is the same angle, then these two have to be congruent to each other. We also have a congruent complements theorem that goes about the same. So let me go ahead and write some numbers here. If this is 30 degrees, and this must be 60 degrees, because complementary means adding up to 90. It says these two must also be complementary, so that forces that to be 30. They are complementary to the same angle, so that means these two must be congruent. Let's prove the first theorem in a two-column proof. Okay, so here's our given. And supplementary means adding up to 180, definition of supplementary angles. And since they're both 180, that's the connection. We can say that they're equal to each other. I would like to get rid of adding 2 on both sides, and that's called subtracting. And then I want to change it to congruence, definition of congruent angles. Here's our next two. One's a postulate, linear pair postulate. When you see two angles in that, making that line, then we know that they're going to be supplementary. Vertical angles. These are vertical angles right here, and we're going to prove that they are congruent in a few minutes, but let me just use some numbers to help you. So if this is 30 degrees, this is a linear pair. Linear pair means they are supplementary, so that's 150. Now here's another line, if that's 150, this is 30, and you can see by the congruent supplements theorem that these two will be congruent, which tells me vertical angles have to be congruent as well. Okay, and here's the theorem in a paragraph proof style. Paragraph proof means your statement and your reason is going to be in sentence form. So they're telling me that we have vertical angles, which is what we have here. Now, because of what the picture looks like, I can say that these two angles, let me put another color in here, I can say these two angles are a linear pair, and I can say 6 and 7 are a linear pair. Now, the postulate right here, the linear pair postulate says you're allowed to say they are supplementary to each other. So we're going to say they're supplementary. They're supplementary. Notice they're supplementary to the same angle. Look at that. Angle 6. It's the same angle right in here. So we can use this theorem right here, the congruent supplements theorem, and say that the leftover angles 5 and 7 are congruent by the congruent supplements theorem. All right, here's a two-column proof, and let's see if we can get through this two-column proof. What we want to do is we want to prove that this whole length is congruent to this whole length right here. Let's take a look from line 1 to line 2. Notice there's an AB and an AB, there's a DE and there's a DE. And it looks like there's a plus, let me change the color. Looks like there's a plus BC and a plus BC. So that makes sense. It's the addition property of equality. Okay, now it says substitution. So we're going to be substituting something. Let's take a look at, we have BC equal to CD. So let me undo this so there's not so much writing here. So we have a BC that we can substitute. So let's write AB plus BC is equal to CD plus DE, and that's the substitution. Now this says AB plus BC is equal to AC. That looks like little plus little equals big. And we can say the same thing about CD and DE equaling this whole thing. So that's called the segment addition postulate. Now notice that we can take this out and replace it with AC, and we can take this out and we can replace it with CE, and that's called substitution. And once it's an equality, it said we have to go one more step, definition of congruent segments. So that tells us we can go back and forth from congruence to equal or equal to congruence. Okay, let's take a look at this problem. This is not a proof, but these are vertical angles, and we know that vertical angles congruent theorem tells us that we can set them equal to each other because they're the same size. So 3x is equal to 147 and x is equal to 39. Okay, we're only going to do one of these problems. Angle 1 is 117 degrees, and we know linear pair says that these are going to be supplementary, so this is going to be 63 degrees. Now, the vertical angles theorem says that we got vertical angles, they'll be congruent. Vertical angles are there congruent. Notice all the supplementary and all the congruence that's going on here. Okay, let's do one more with vertical angles. We're going to set them equal to each other. And we get 95 is equal to 5W, and W is equal to 19. Okay, let's write a paragraph proof on this. We're going to be given angle 1 is congruent to angle 3. So by the given, we know angle 1 is congruent to angle 4. I'm just using sentence format. Okay, angle 1 is congruent to angle 2 by the vertical angles congruent theorem. And I can see this connection with angle 1. So by the transitive property, angle 4 is congruent to angle 3. Now that's not what I want to prove yet, so I got to keep going. Let me say that angle 3 is congruent to angle 4 by the vertical angles theorem. And I see this new connection here. This connects with this. So by the transitive property, I can say angle, oops, I did something wrong. 3 by the transitive property. This should have been a 2 right here. So 4 and 2 should have been there. And the connection was not here, but the connection was here instead. So now I can say angle 2 is congruent to angle 3. All right, so you guys can see that I make mistakes. All right, let's go to the last slide, and the last slide is kind of a summary of what we've been talking about. There are 3 types of proofs that we can do. One of them is a 2-column. One of them is a flowchart proof, or we just say flow proof, and the other is a paragraph proof. This is the statement we're trying to prove, and they're proving it in 3 ways, the same proof. And this ends the screencast.